Without technology, when they give us a non-standard, not standard normal distribution, where the mean is not 0 and or the standard deviation is not 1. So we've got mu equals 100, sigma's 15. To do this with a table, because they cannot make a table for every possible mean and standard deviation. To do this with a table, we have to convert this to a z-score, and you convert it to a z-score by taking your given x value, in this case 110, this is x, getting the distance from x to the mean, and dividing by the standard deviation to determine how many standard deviations this distance would qualify as, and that's our z-value. A z-value is nothing but the number of standard deviations that you're standing to the left or the right of mu, of the average. So in this case, z would be, our x value is 110. We would do 110 minus 100 mu divided by 15. That's going to be 10 over 15, which is 2/3, which is about 0.67, because they usually let z-values go 2 decimal places, probabilities go 4. So then we would have to convert this to a z-value, go to the table. The second page has positive x values. So we would look up 0.67 by going down here to the 0.6, across to the column with the 0.07 in it. So 0.67 would be 0.7486. And that's going to be to 2 decimal places. Instead of that, we're going to use a technology in StatCrunch which does not make us do any converting to a z-score. So I want to go to the question help, pull up StatCrunch. Remember the 0.7486. I'm going to clear that out so it won't be all over the StatCrunch. Go to Stat, Calculator, Normal. This time, in place of the 0 in the mean, we're going to put the 100. In place of the 1 in the standard deviation, we're going to put 15. And to calculate the probability that the x lies below or to the left of 110, I put in 110, I hit compute. Notice the graph matches the graph in the picture. The probability is 0.7475. It may not come up with 100% exact amounts, but it's going to be close enough to where nobody's going to notice. Now, my math lab is going to be, if there's a difference between what the table gives and what StatCrunch gives, it's going to be programmed to accept either answer. In a between problem like this, I just calculate the between. The mean is still 100, standard deviation is 15, check, check. Now I want to know how much of the area is between 80 and 115. So I'm going to change this to an 80. I'm going to change the top number to 115. Just hit compute. Graph matches. And the probability is 0.7501. And notice this problem had already been worked, and that's what they got. In this problem, they're giving us the probability Now, once again, they've left it, these are IQ scores. So this is typical for an IQ test. The mean is 100, standard deviation is 15. So that's still the same down here. I need to put this back on standard for just one value. And so instead of putting in a z-score or an x-score, I'm going to put in the probability as 0.97. And it turns out that 97% of the IQ scores are going to be less than or equal to 1.28.2. 97%. So if you run into somebody who claims that they've got an IQ of 160, take it with a grain of salt. Now in this problem, they're wanting us to find the probability that an adult has an IQ between 95 and 115. So we want to go to the between. They've changed the mean now to 105. Left the standard deviation at 15. So between 95 and 115, I actually only have to change this first number to a 95. The second one's already 115. Probability is going to be 0.495. So we're talking about half. Half the people's IQ is going to be between 95 and 115. This problem's a little different. It says, engineers want to design seats in commercial aircraft so that they are wide enough to fit 99% of all males. Accommodating 100% of males would require very wide seats. Men have hip breadths that are normally distributed with a mean of 14.7 inches and a standard deviation of 0.8 inches. And they want us to find the percentile at 99. This means to find the cutoff between the bottom 99% and the top 1%. So there's only one number I need to put in here. So I'm going to change this. I'm going to change my graph back to a single entry. To find the cutoff at 99%, well, the mean and standard deviation have changed. So mean is going to be 14.7. Standard deviation is going to be 0.8. I want to find the probability for 99%, so that is 0.99. Your probability will always be somewhere between 0 and 100%, which is between the number 0 and 1 as a decimal. So it's always going to be smaller than 1, or no more than 1 for sure. So hit compute, and it is X has to be less than or equal to 16.56. And this actually asked for it to be rounded to 1 decimal place, so the answer before was 16.6. Let's take a look at this one. A survey found that women's heights are normally distributed with a mean of 63.9 inches and standard deviation 2.2. And a branch of the military requires women's heights to be between 58 inches and 80 inches. Okay, 80 inches is huge. That's like 7.5 feet. Don't think that's going to be a problem. 58 inches is 4'10". So find the percentage of women meeting the height requirement. Are many women being denied the opportunity to join this branch of the military because they are too short or too tall? So let's see what percentage of women are going to fall between 58 inches and 80 inches. So the mean is going to be 63.9. Enter that. Standard deviation is 2.2. Oh, I need to put this on between, don't I? Okay, so between 58 and 80, I'm just going to put literally between 58 and 80. These are X values. These are not probabilities. The probability is going to be 0.9963. So the percentage of women that fall in between these heights is 99.63% of women. They've got the percent sign there, so I know to move the decimal. And it says 2 decimal places. Part B. Well, it's just asking, are many women being denied the opportunity? I would think not, since less than 0.5% of women would not be in between those heights. So that should put you in pretty good shape to do this homework. Let me know if you do have any problems, and I will talk to you later.